All right, let's look at the first one. The standard form of a conic is ax squared plus bxy plus cy squared plus bx plus ey plus f is equal to 0. It might look complicated, but it's not. Now, for parabola, we have a is equal to 0 or c is equal to 0. For circle, we have a equals c. For ellipses, we have a is different than c. Now, it might look complicated, but once you get to it, it's very simple.
It's easier than memorizing
It is not a good idea to actually memorize. It's better to actually get to it. So I will jump through. I will not try to waste time reading this one. So let's go ahead and jump through and look at the problem number 1. We're going to use our calculator. So go ahead and get your calculator. On problem number 1, the first thing I want you to do is solve for y. So let's go ahead and solve for y. To solve for y, I will subtract x squared from both sides. And I will be left with y squared is equal to 25 minus x squared.
D1 squared minus y equals 5.
What was that?
Then D1 squared minus y equals 5 minus x.
No.
Or D9.
You leave it as this. Now, from here, the next thing is to find the square root, but you don't get what you just said. Once you find the square root, who can tell me what exactly I will get? Y is equal to what?
5 minus
Square root of 25 minus x squared,
is minus x squared in the
or
curvature.
y is equal to the negative of square root of 25 minus x squared. Remember, every time you bring the square root, you need a plus and minus. And no, you cannot say 5 minus x. You do not find the square root like that. If it's a product, yes. If it's a sum or difference, you do not break the square root into both.
Will we answer x cubed?
We will get to it. Alright, at this point, what I want you to do is, on the y equal, I want you to graph those two equations. So on the y equal, the first one I will have is 25 minus x squared. And on the y2, I will have negative of the same thing, meaning 25 minus x squared. Yes, you cannot take it out of the radical.
0?
Zoom 6. I want you to stay on your standard zoom. Look what I get. It looks like an oval, but is it an oval? Let's go ahead and see. What do you think the center is? What is the center?
0.
0, 0. Now, from the center, how many units above? 5. How many units on the left?
5.
On the right?
5.
On the bottom?
5.
So what is it? It's a circle. You got to be careful. The side thing is the calculator will show you something. You got to know what it is. Well, we find out that this is a circle. So here, I can graph it knowing that this is 5. And you build your circle. The one I built. Circle. Let's go ahead and look at the second one. For number 2, we will solve for y as well. Let's go ahead and solve by first subtracting the 4x squared from both sides. And if you subtract, you end up with 25y squared is equal to 100 minus 4x squared. What would be the next step? Divide by 25. You will get y squared is equal to, what is 100 divided by 25? 4. And if I have 4 over 25, I will leave it as 4 over 25 x squared because I cannot simplify that. Remember, once I bring the square root in it, what will happen? It will bring a plus and a minus. You understand that, right? The square root will always bring the plus and the minus. So let's go ahead and put that on the calculator now. So on the y equal,
So it's y equals 4 square root of minus 4 over
You
25.
type exactly what you had there. 4 minus, I will go ahead and make mine fancy, have the exact fraction. That'll be 4 over 25
Square.
x squared. And the other one would be negative 4. You do this alpha y equal. After minus, you do alpha y equal. It brings this. You press 1, it brings your fancy ratio. 4 over 25.
Can you still do like parentheses?
You can use parentheses. It will not change the answer. All right, and I will graph it. This time, look what I see.
Ellipse.
You meant ellipse?
Yeah, ellipse.
Yes. This one is obviously an ellipse. You want to know why? Because this is still the center. Let's count. 1, 2, and 1, 2, 3, 4, 5. That's an ellipse. You have two types of ellipses. You have horizontal and vertical ellipses. Which one is this one?
Horizontal.
Obviously it's horizontal because it's laying on a horizontal line. So you can graph this one on your paper as well, knowing that it's going to be something like this. And I will call it that's an ellipse. All right, let's go on to the next page. On the next page, I want you to solve for y again, because it keeps saying using the graphing calculator. If you solve for y here, what will you get? Y squared is equal to x over 4. Then you find the square root on both sides. You will get y is equal to plus or minus square root of x over 2. Now you can split them. On this one, you don't have a plus or a minus in the equation. So you can break the square root for the top and square root for the bottom. Let's go ahead and put this on the calculator to see what we get.
Wait, do we put plus or minus?
You're gonna have to separate it on your calculator. One of them will be positive and the other one will be negative. Yes, because it was square root of 4 also, but the square root of 4 is 2. So I remove the radical.
So is it x?
Or on your paper, you can, on your calculator, if you feel like, you can put this. X over 4. It's the same thing, right? So here I can also put x over 4.
Not square root. I mean, not.
With the square root, of course.
Wait, so that's negative?
I thought it was x over 2.
Now, it depends. If you put the 4 inside the radical, then it's 4. If you take it outside, it's 2. Because if you find the square root of 4, you get 2. You see the difference?
I thought we wrote that.
I mean, yes, we wrote, but I'm just showing you that it's the same thing here. Whether you put a big radical or you split it into two small radicals. All right, let's go ahead and graph it and tell me what you get.
The triangle things.
You get this.
I got the triangle thingy.
You get this. What exactly is that? A parabola. Is it what kind of parabola? It's the horizontal. The one you're familiar with is the vertical. The one the regular y equals x squared. The horizontal looks to the left or to the right. So this is a horizontal parabola. Later on I will show you, because you see how I just graphed it? It's kind of wrong, because normally there are rules on how to graph these parabolas. We're going to get to it on no, the parabola, the start touching the parabola all the way till the 23rd. We got other stuff to do before then.
I think I'd rather be weekend.
Problem number 4 now. You have x squared minus y squared is equal to 16. Go ahead and solve for y again. To solve for y, you can either move it over here or leave it there. So I will leave it there. I'll have negative y squared is equal to negative x squared plus 16. Then I will first multiply everything by negative to get y squared is equal to x squared minus 16. Why did I multiply by negative?
Y was negative.
Y was negative, and in other words, you cannot find the square root of a negative number. You got to turn it into positive. So let's find the square root on both sides. You're going to get two equations. One of them will be y is equal to negative square root of x squared minus 16. And the other one will be y is equal to regular square root of x squared minus 16. Quick question.
You do that because you had the square root of y, right?
Yes, you always bring plus and minus. Here's a question for you since you're sleeping.
Okay.
What is this equal to? Is it equal to x minus 4 or x plus 4 or none of the above? None of the above. You cannot split it with the sign in between. Go ahead and put this on your calculator. After putting your equation, if you graph it, this is what you see now. You see how beautiful it is?
It's a hyperbole.
That's not hyperbola. Now, hyperbola, notice that it's double parabolas. So a parabola on the left and a parabola on the right. Is it horizontal or vertical?
Horizontal.
Horizontal. Very good. So make sure you write horizontal on your paper. Now, something that is very important on the hyperbola is the location. You got to know where the center is. It's at 4 units. So
0.
when graphing it, you got to have, I'm talking about these points, 4 at each. So make sure you, at 4, that's when you graph it. And of course, it's a hyperbola.
Wait, why do you have the squared on the x instead of like at the end?
I don't get it. The question.
Oh, never mind.
Okay.
Last one we had like square at the end.
It depends on problems. It depends. This x squared, it depends on the problem. It started with an x squared.
Yeah.
All right, let's keep going. Midpoint formula, distance formula. This is good old school. You should remember how to find the middle of anything or use the distance formula. The midpoint formula says when you have 2 points, coordinate x1, y1, x2, y2, the midpoint will be x1 plus x2 over 2, y1 plus y2 over 2. And for the distance, it's the square root of x1 minus x2. It can be x2 minus x1. It won't make any difference because it's being squared. Plus y1 minus y2 squared. Here we have 2 points. The first thing I would like to do is call this one x1, y1 and x2, y2. The reason I'll give them names is because I want to make it simple for me. Now they say find the center and the radius of the circle that has a diameter. In other words, if this is the circle and we have a diameter here, the coordinate of this point may be 9, 4. And for this point, it might be 3, 12. And we want to first know the center. And after we find the center, we can write the equation. All right. Let's go ahead and find the center. Use whatever tool you can to find the center. Once you find it, let me know. You understand that the midpoint is also the center, right? So if I use the midpoint formula, I will find the center. Now, I have 3 plus 9 over 2. What's 3 plus 9? 12. Divide by 2, 6. 12 plus 4?
16.
Divide by 2?
8.
8. Note that all you found there was the center. Now that you got the center, to know the radius, you have 2 ways of finding the radius. You can find the distance between the center and any of these points, or you can find the distance between these two and do what? Divide by 2. Because if you get the diameter, divide by 2. Now, which one do you want to use?
Just this.
We're going to use the distance regardless. Which, with the center?
Yeah.
Now, here's the problem. Imagine you get the center wrong. That means you're getting the radius wrong. I'd rather you use these 2 points because they were given to find the diameter and divide by 2. You see the difference, right? Because if you get this one wrong, you're carrying the wrong answer over and over again. Compared to these two, you didn't get it, so they're right. Use those two, get the diameter, and divide by 2. So let's start with the diameter. For the diameter, I will say it's the square root of x1 minus x2, 3 minus 9 squared, plus y1 minus y2, 12 minus 4 squared. That's again to find the diameter, which is equal to the square root of 3 minus 9 is negative 6 squared, which is 36. Very good. 12 minus 4 is 8. 8 squared is 64. 36 plus 64 is 100. Square root of 100 is 10. 10 is the diameter. Therefore, what is the radius? Radius is equal to diameter over 2, 10 over 2, which is 5. So this is an important information. This is important.
Radius is 5.
Yes. Any question? All right, let's go ahead and look at the next one. This time it says, find the center and radius of a circle that has the diameter with endpoint 2, 6, 14, 12. Shall I let y'all work it? And I'll put the answer in a minute. Now, your answer will be, you will have a center of 8, 14, and the radius will be 10. 10, whichever one is the unit.
Wait.
A circle is a set of all points such that each point is an equidistant from a given fixed point. What is that given fixed point?
Center.
Called center. The ellipse is the set of all points such that the sum of the distance from xy to the two fixed points f1 and f2 is constant. Who are f1 and f2? In an ellipse, let's pick a point. We have 2 points f1 and f2 somewhere here. Those points are called focal point. Later on, I will explain this more. Those points are called focal point, f1 and f2. They're somewhere here. They're saying that the distance xy to the fixed point. So if I get any point from here to here, if I find this distance, it remains constant, regardless of the position on the ellipse. Let me show you a very quick example. Let's say this is f1 and this is f2. I'm saying this distance from here to here, if I add these two, or I add these two, or I add these two, they should always be the same thing. That's what makes an ellipse. It's something cool like that.
What's that last one?
Constant? All right. Example of an ellipse. That's more 3D. You think about it. Keep thinking. Let me know when you find a real life example.
Can we just get parabola online later?
Yes. If you feel like getting it, I'll get it.
I feel like you're really smart.
We have set of all points such that each point xy is an equidistant from a fixed point called focus and a fixed line called directrix. And below here you have better pictures. This shows you the hyperbola, the circle, and so on.